class, we're going to start Geometry B Credit 1. This credit is titled Quadrilateral, so we're going to actually talk about what a quadrilateral is and all the properties of quadrilaterals. This is going to be the first lesson, lesson 9.1. So let me go to the lessons for this credit. We're going to focus on lesson 9.1, properties of parallelograms. And the learning goal is to prove and apply the following theorems about parallelograms, which are opposite sides are congruent, opposite angles are congruent, and the diagonals of a parallelogram bisect each other. So let's go to lesson 9.1, and we're actually going to look at this page really quick. So this is on page 8. Now, again, if you guys do not have the packet, do not worry. Just try to take notes on a separate sheet of paper. Do some drawings of different shapes that we're going to be talking about. But what I want to do is I want to focus on this diagram below here. So this diagram pretty much sums everything that we're going to be learning in this lesson. This entire credit talks about quadrilaterals. A quadrilateral is a four-sided shape. Now there are different types of quadrilaterals. There are trapezoids, and a trapezoid has two parallel lines, so top and bottom are parallel lines. There are parallelograms, so this is called a parallelogram. And a parallelogram has two pairs of parallel lines. So these two lines are parallel to each other, and these two lines are parallel to each other. Next, we have a kite. So kites have no parallel sides. And then in this lesson, I think, yeah, let's go to page 10, and we're going to actually start here. So properties of parallelograms. First, what we're going to be doing is we're going to define what a quadrilateral is, and they kind of tell us above here, a quadrilateral is a polygon with four sides. So as long as you have a four-sided shape, that is called a quadrilateral. And a parallelogram is a quadrilateral that has two pairs of parallel sides. So over here where it says definition of a quadrilateral, what we're going to be doing is we're just going to be drawing a four-sided shape. So because this is a quadrilateral, any quadrilateral, it could be any four-sided shape. So this has four sides. This is a quadrilateral. Okay. Next, we're going to be talking about a parallelogram. So remember, parallelograms have two pairs of parallel lines in it. So let me draw one pair of parallel lines, and let me draw another pair of parallel lines. Now, when we say something is parallel to each other, we want to use these little arrows. So what these arrows tell us is that this line is parallel to this line. And we want to use the same thing, but now we want to use two arrows to show that this line is parallel to this line. Okay, and then let's actually start looking at some theorems about parallelograms. So this is on page 11. the first theorem of a parallelogram states that if a quadrilateral is a parallelogram, then its opposite sides are congruent. So if we have a parallelogram WXYZ, then the opposite sides would be congruent. So WZ, this side, is congruent to XY. So this is what it says right here. Segment WZ is congruent to segment XY. And then WX is congruent to ZY. And we could actually use tick marks to show that they're congruent, which we kind of saw in the first semester of geometry. So if I want to say that this segment is congruent to this segment, I'm going to put a little dash here and here. This tells me that this segment is congruent to this segment. And if I want to say WX is congruent to ZY, I'm going to put 2 dashes on both segments. Okay. We're going to be using these theorems as we go on when we're trying to do or solve for problems. But let's, again, just focus on opposite sides are congruent to each other. So if this side was 5, then this side is 5. If this side is 12, and then this side is 12. That's all we know, that opposite sides are equal to each other. So below we have a proof, and what we're actually going to do is we're actually going to be skipping this proof just because it kind of relates to what we're going to be doing in this lesson, but not so much. So let's move on to the next theorem. Okay. So theorem 2, if a quadrilateral is a parallelogram, then its opposite angles are congruent. So we have a quadrilateral that's a parallelogram, and what this theorem is telling us is that the opposite angles are congruent. So ZWX, this is an angle, and that is this angle. So I'm using an arc to show that this is the angle ZWX is congruent to XYZ. XYZ. Remember that to label an angle, if you use 3 points, it's the middle point that is the angle. So XYZ is pretty much angle Y. ZWX is angle W. So this is XYZ. This is angle XYZ. So this angle is congruent to this angle. This is what this theorem is telling us. Opposite angles are congruent to each other. So that means that WZY, so angle Z, is congruent to angle WXY. So I'm using one arc to show that these two are congruent, and I'm using 2 arcs to show that these two are congruent. And again, we have proofs, but again, we're going to be skipping those proofs for now. Okay, now let's go on to our third theorem. Our third theorem talks about diagonals. So again, if a quadrilateral is a parallelogram, then the diagonals bisect each other. So let's kind of talk about these words, diagonal and bisect. Remember the word diagonal. A diagonal is a line that cuts between 2 angles or 2 points. So this is a diagonal, WY, and this is another diagonal, ZX. Now, bisect means that these diagonals cross so that these sides are the same length and these two sides are the same length. Pretty much what that means is that this entire piece, WY, is congruent to XZ. So if WY was 6, then XZ would have to be 6. So this entire line is equal to this entire line. This piece of the diagonal is equal to this piece of the diagonal, and the same here. This piece is equal to this piece. Okay, and then again, we have a proof below here. So again, we're going to be skipping some of these proofs, and our focus is going to be on using these three theorems to solve problems. So on page 14, let's kind of recap what these theorems are. So remember theorem 1, if a quadrilateral is a parallelogram, then remember that theorem 1 talks about congruent sides. So we could use a tick mark. This side is congruent to this side, and this side is congruent to this side. Now, theorem 2, if a parallelogram or if a quadrilateral is a parallelogram, then theorem 2 tells us that the opposite angles are congruent to each other. And this kind of shows you what we're going to be using to show congruency. So this is how we show an angle is congruent to each other. We use a little arc. So we're pretty much saying that angle A is congruent to angle C. And then we're saying that angle B is congruent to angle D. That's what theorem 2 tells us. And then the third theorem, so if a quadrilateral is a parallelogram, then its diagonals are congruent. So if I was to draw a diagonal from A to C, and another one from B to D, we could say that AC is congruent to BD. Okay, so now let's use these theorems to solve problems. And we're actually going to be going straight to page 16. Okay, so now these examples are already completed for us, but I'm just going to walk through these examples for you. It's just so that you understand what we're doing. For problem number 1, we want to find the length of AD. So AD is a side, and if we are talking about sides, we're pretty much focused on theorem 1 because we know opposite sides are congruent to each other. So we could create a equation that tells us segment AD is equal to segment BC. So AD equals BC or CB. And then what we could do is we could substitute what AD and CB are. So we have 7x is equal to 5x plus 19. We could solve for x by moving the 5x to the other side. So they subtracted 5x and they got 2x. Then we divide both sides by 2 and then we get 9.5. X equals 9.5. Now that we know what x is equal to, we could solve for AD by substituting the value for x in for x, or in for the expression for AD. AD is equal to 7 times x, or 7 times 9.5, which becomes 66.5. So for this problem, we used Theorem 1. Opposite sides are congruent. Okay, now for problem number 2, they want us to find out what angle B is. So in this quadrilateral, or in this parallelogram, angle B is 6y plus 5. Angle D is 8y minus 17. And what we could do is we could use Theorem 2, which is opposite angles are congruent, to solve for y, and then we could solve for angle B. So we set up the problem as angle B is congruent to angle D. Then we substitute 6y plus 5 equals 8y minus 17. Doing some algebra, you could subtract 6y to the right side. We get 2y. And then we could add 17 to the left side, and we get 22. I could divide both sides by 2, and I get y equals 11. So now that you know y is equal to 11, you could plug in 11 in for y, because what we're trying to do is we're trying to solve for angle B. So the measure of angle B is equal to 6y plus 5, or 6 times 11 plus 5. 6 times 11 is 66, and 66 plus 5 is 71. Because we're talking about angles, we use degree symbol, so this is 71 degrees. Okay, so now you're going to try a couple problems. And we're going to actually work this together. So looking at problem number 1, we want to solve for x. We know this is a parallelogram. So if this is a parallelogram, we could create an equation where we say BC is equal to AD. So let me write that over here. BC is congruent to AD. And let me zoom on this problem just so you guys can see. So then if I substitute, I have 16 is equal to 6x minus 2. I could add 2 to both sides. These cancel each other out. I get 18 is equal to 6x. And then I could divide both sides by 6. So these cancel out, and I get x equals 3. And that's what we wanted to do. We wanted to solve for x. We solved for x. Okay, next, number 2. We want to solve for x again, and this one involves angles. So we have angle E is 72, angle C is 17x plus 4. So as you guys are doing these problems, I want you guys to pause these videos and attempt these on your own, and then play to see the correct answer. Theorem 2 tells us that opposite angles are congruent. So I could say angle C is congruent to angle E. Then if I substitute, I have 17x plus 4 is equal to 72. I could subtract 4 to both sides. 72 minus 4 is 68. And then I would divide both sides by 17. And 68 divided by 17 is 4. So that is your solution. Okay, let me zoom out. Next, for problem number 3, we're given this quadrilateral, and they want us to find QR. So QR is a side, and what I could do is I could set this side equal to this side. QR is equal to PS. So QR is congruent to PS. Then if I substitute, QR is 3Z minus 4, and PS is 2Z plus 4. I could subtract 2Z to both sides, and I get Z minus 4 equals 4, and then I could add 4 to both sides. And you end up getting Z is equal to 8. So then, does that answer our question? Actually doesn't. We know Z is 8, and we know we're going to use that, but the question is, what is QR? We want to find out what this length is. What we do is we're going to substitute this solution in for Z. So I'll do this right here. QR is equal to 3Z minus 4. And then if I plug in 8 for Z, I get 24 minus 4, which is 20. So QR is equal to 20. Okay, and then the last problem, they want us to find out what PR is. Now, PR is a diagonal. Theorem 3 tells us that diagonals bisect each other. And what, again, that means is that the distance from S to T is the same as T to Q. The distance from P to T is the same as from T to R. This distance, PT, is equal to TR, and we could actually start there. We could say PT is equal to TR. Then we substitute, PT is x plus 9, TR is 4x minus 6. Then doing some algebra, I could subtract x to this side, and I get 9 is equal to 3x minus 6. I could add 6 to both sides. And I get 15 is equal to 3x, and I could divide both sides by 3, and I get x is equal to 5. So x equals 5, but that does not answer our question. Our question is, what is PR? What we know is that PR is equal to PT plus TR. So this entire length is equal to this piece plus this piece. So that's equal to x plus 9 plus 4x minus 6. And if I plug in 5 for x, I would get 5 plus 9 plus 4 times 5 minus 6. 5 plus 9 is 14, 4 times 5 is 20, and then minus 6. 14 plus 20 is 34, minus 6 gives me 28. So PR is equal to 28. Okay, so now for your homework. This is lesson 9.1 homework. There are 5 problems on page 18. And again, if you do not have a packet, please do this on a separate sheet of paper. Make sure you label your homework. So make sure you label it on top, lesson 9.1 homework. Make sure you write your name, first name, last name on the top. And then when you're doing your homework, you can choose to draw these quadrilaterals, or if you don't need them, if you don't need to draw them, then just create the equation and solve for x or solve for whatever they're asking. For questions like number 5, you could just write A, B, C, D, E, F, and either a Y for yes and a no and a N for no. So like, let's say that you say A is a yes. So you're just going to write, I'll do it on the side, you're going to write A and then a Y. So this tells me that you said yes for A. And if you want to say no for B, you're going to put an N for B. So again, that's if you do not have a packet. And then you have the lesson 9.1 checkpoint. So when you finish your homework, when you finish the 9.1 homework and the 9.1 checkpoint, what you're going to be doing is you're going to be taking a picture of these 2 pages, and then you're going to be submitting them where it says 9.1 homework and checkpoint. And that's how I'm going to collect your work. All right, and have a good day, guys.